Number 29. Now this picture didn't come out that great, but over here it says that the p-value is 0.052. P-value is 0.052. And the null hypothesis is no change. So if you subtract them, you would get a 0 because they're both the same thing. We don't really care what's going on. This is just the information we got. So what's going to happen here? Well, at an alpha level of 0.05, we're going to fail to reject, which means it's possible that there's no change and we would have a 0. Now if we think about the confidence interval, there has to be a possibility that there's a 0 in the interval. Which one of these contains a 0? Letter B, from negative 0.25 to 0.01, there's a 0 inside that. None of the other ones contain a 0. So it's got to be letter B. Right there. Okay, on this one, number 30, let's see. Jason's golf scores are, well, the average is 90, standard deviation of 6. Mark's is 85, average, standard deviation of 8. The picture didn't turn out that great, but Mark's score minus Jason's score. Mark's score minus Jason's score would give us a result of -5. That's what we should expect. And then the new standard deviation. Well, you take the old standard deviations, right? We square them, we add them, and we take the square root. We never subtract them. There it is. Now if you do that, you get 10. So we should expect -5 and 10 for the new standard deviation, which is letter C. Square them and add them and take the square root. Should be a dance move for the drill team. Okay, so sampling can be kind of confusing. Simple random sample is when you just number them, right? And then you just use a random number table, or you put their names on a slip of paper, throw them into a hat. That's simple random sampling. We don't really cover systematic sampling, but convenience sampling is first 100 people through the door. That's your sample because it's easy to do. Cluster sample and stratified sample. Okay, so this is a stratified sample because they took the downtown locations and they took from that group of downtown locations suburban locations, and they took from that group, and then 10% from standalone locations, and then they put them all together. Okay? A cluster sample is when you would take some from each of those locations, right? Throw them into a big bin, and then take your sample from that. Okay? Stratified, taking them from each one first and making your sample, versus throwing them all into a big bin and then making your sample from that. I know that's kind of confusing, but hopefully that helps. Oh, by the way, the answer is E. So a lot of times, these types of questions, number 32, we're talking about what is kind of a definition of our confidence interval, which we got for one single sample was between these two numbers. So a lot of times in the answer, when they start using these numbers, this interval, that's not right. Okay? This is just one single interval that we got. Okay. The other intervals that we could do with other samples, we would get different numbers. The answer is A. I know a lot of times in these questions, they make you read all of these, right? And it's always like D or E when you get confused. I was a little suspicious because right away, I was like, wait a minute, A sounds correct. And it is correct this time. 32. So here, basically what we're saying is if the difference is large, a small sample will suffice. But if the difference is small, it means that she wants to increase the sensitivity of the test. She wants better data. And how do we do that? Increase the sample size. And what happens when we increase the sample size? We increase the power of the statistical test. Yes, letter A.